Welcome class, thank you for joining me for this second half of our 3.2 notes. Today we are going to shift our emphasis. We are still going to be solving systems of equations. However, today we are going to focus on the elimination method. Now, just a really quick review. Substitution method. What were we looking for? Well, for the substitution method, we were looking for an isolated variable. We wanted one of our equations already solved for one of our variables. Today, that's not what we are looking for anymore. Today, for the elimination method, what we're looking for is a variable that has the same coefficient in both equations. So, that's kind of our goal. That's what we're looking for. In our two equations, today we need to identify a variable that has the same coefficient. Now, when I say same coefficient, it could be the same positive or negative. So, what I mean by that is look at our first example. So here, those two x's could work because there's a 2x and a 2x. Or the y's could also work for this process because you have a 3y and then you have a negative 3y. Now I'm going to focus on the y's this time because in our next example I'm going to end up focusing on the x's. So I'm going to focus on those y's. Again, one is a 3y, one is a negative 3y. So they basically have the same coefficient. One is positive, one is negative. When they have that opposite relationship, what we're going to end up doing is adding the equations. I'm going to add the entire first equation with the second equation. So let's take a look at what that looks like. Well, when I add these together, I have 2x plus 2x. Well, that's going to give me 4x. 3y plus a negative 3y. So essentially 3y minus a 3y. That's going to end up canceling off or eliminating from my equation. That is the whole point of this process, is we are looking for one of our variables to be eliminated from the equations right off the bat. And then I need to add the other side as well. 5 plus 11 is 16. Divide both sides by 4, and we already have one of our variables solved for. Now, as you remember from substitution, hopefully, we're not quite done yet. We need to figure out what y is. Now, to get y, we merely have to plug this into either equation. We pick one of our equations to plug it into. I'm going to choose the top one. So I'm going to put 4 in for x, and then I'm going to solve that equation for y, because that'll give me both my variables. So I get to this point, I'm going to subtract 8 from both sides, divide by 3, and now I have both of my variables. So I can label out my solution as a point. So that is going to be the basis of our elimination method. Slightly different than substitution. Again, with the goal being we're looking for something with the same coefficient in both equations. Now, when you flip to this next page, so I'm looking at my two equations and I'm looking for a variable that has the same coefficient. This time, I'm going to identify those x's right there. Okay, 2x and 2x. So this time, they have the same sign. When they have the same sign, we're going to end up subtracting our equations. All right, and the reason that we're going to subtract our equations is because that is the way to get them to cancel this time. So I'm going to subtract the whole second equation from the first equation. So 2x, and I'm minusing 2x. That's going to cancel off. Okay, that is how I eliminate when they're the same, because you need to subtract it away. Same minus the same. Now, 7y minus a negative y. Now, here we have to be careful because we need to remember subtracting a negative. That means we're actually adding that on. So 7y minus a negative y is essentially 7y plus 1y. And I'm going to get 8y. Negative 12 minus 4 gives me negative 16. I'm going to divide both sides by 8. And that's going to give me y equals 2. And again, now we have to pick one of our equations to plug this into. And again, it doesn't matter which one that we choose. So I'm going to choose my bottom one this time to show you that that works too. So 2x minus y equals 4. Well, so minusing a negative, again, that's essentially 2x plus x, or 2x plus 2 equals 4. Subtract 2 from both sides, divide by 2, and I already have my x solved for. So that means my solution is going to look like that. So those are our two ideal cases where we have a variable that's the same coefficient, either opposite sign or same sign, in both equations. Now, that won't always be the case. So let's look at number 3. So looking at number 3, if you notice, neither the x or the y has the same sign here. So we're not going to get to use that ideal case. So what can we do? Well, I'm going to notice my y's. Okay, notice I have 6y and 3y. So if you recall way back from Algebra 1, if I were to multiply the second equation by 2, remember that doesn't change the solution to the equation. It doesn't really change the equation at all. However, if I do that, I'm just going to rewrite the top equation. Now, if I were to multiply the bottom equation by 2, notice what happens. When I do that, now I have that relationship I'm looking for in my y's. Now they have opposite signs, so if I were to add these two equations together, now my y's will cancel off like I need them to. So that's the point of this example, is to show you that if you don't have your variables lining up properly, you can always multiply one or both of your equations by something, so they will end up lining up. All right, so let's finish this off. 5x plus 16x gives a 21x. 32 plus 52 leaves me with 84. I divide by 21, and I get x equals 4. Now remember, I'm not done though. I need to plug that into one of my equations. So I'm going to plug it into that one right there. So 5x, so 5 times 4, minus 6y equals 32, which means 20 minus 6y equals 32. I'm going to subtract 20 from both sides. So negative 6y equals 12. Then divide both sides by that negative 6. So you're going to get y equals negative 2. So if I wanted to write this as a point, that is going to be 4, negative 2. So again, our goal is always the same. We always have to find that pair of coefficients that has the same coefficient. Now, let's take a look at a word problem. Roast beef has 25 grams of protein and 11 grams of calcium per serving. A serving of mashed potatoes has 2 grams of protein and 25 grams of calcium. How many servings of each are needed to supply exactly 29 grams of protein and 61 grams of calcium? All right, so we need to identify here what we're looking for. So we need to figure out how many servings are needed to supply that much protein and that much calcium. Okay, so to begin to answer this question, the first thing I'm going to do is label my variables. And again, to identify that, I need to figure out what am I being asked. I'm being asked how many servings of each are needed. So my two variables are going to be based on my servings. So X, I'm going to make servings of roast beef, and my Y is going to be my servings of mashed potatoes. Now we have two things we're talking about as well. We're talking about protein and calcium. So we have the amount of protein and calcium in each one, and then how much total we need. So I want us to consider if there's 21 grams of protein in roast beef. So we're getting that 25 with every serving, and we have X servings. We're also getting 2 grams of protein for every serving of mashed potatoes. So 2Y. And how much protein are we looking for in total? Well, we're looking for 29 in total. So let's do the same thing with the calcium. So I'm getting 11 grams of calcium for every serving of mashed potatoes and 25 with every serving of, roast beef. And then this 25 goes with my mashed potatoes. And I want a total of 61. Now here we have kind of a dilemma, all right? Because notice the equations that we just made. Well, they're not turning out nicely. Neither variable has the same coefficient in both equations, and neither one of them are a multiple. 25 is not a multiple of 11, and 25 is not a multiple of 2. So this one's a little bit more complicated than even that example 3. When this circumstance comes up, the little trick that you can always use is you can always flip-flop those coefficients. So I need to multiply these equations by something, obviously. Well, I'm going to pull up that 11 and multiply my top equation by that 11. And then I'm going to pull down that 25 and multiply my second equation by 25. So if you do that, this will always end up working because let's look at the equations we end up getting. So my whole first equation is multiplied by 11. So I'm going to get 275x plus 22y equals 319. Absolutely everything was multiplied by 11. And my bottom one, everything was multiplied by 25. And now notice what happened when I did that. Now my x's line up the way that I needed them to. So that's my little trick for you on how to do these. So just flip-flop those first coefficients to multiply the opposite equation. Now you'll be able to solve this. So 275x minus 275x cancels out just like we need it to. 22y minus 625y is a negative 603y. 319 minus 1,525 is a negative 1,206. And when I divide both sides by negative 603 to get the y by itself, I get 2. All right, so I have one of my variables, and now I need to go back and put it in to solve for one of the others. Now, the cool thing here is you can go back to one of your original equations, so you're working with smaller numbers. So I'm going to go back to that equation, the 25x plus 2y equals 29. Again, when you're plugging it in, you can always go back to one of your original equations. So I'm going to plug it in. So I have 25x plus 2y, which I know is 2, equals 29. So I have 25x plus 4 equals 29. Subtract 4 from both sides. Divide by 25. And you have both of your variables now. So that means I'm ready to write my answer. And again, for word problems, remember, I'd like you to answer in context of the question. So the x equaling 1 means you have 1 serving of roast beef, and the y equals 2 means you have 2 servings of mashed potatoes. Oh, and that is going to be your final answer for this problem. So I just have one more concept I would like to share with you in this video before we wrap up. There are special cases. What I mean by special cases is sometimes when you're solving, the variables will both cancel out. Now, when they both cancel out and you're left with a true statement, you guys know that that means there's infinitely many solutions. When the variables cancel out and you're left with a false statement, that means no solution. You've come across this before, back when we were solving just normal equations. So this really shouldn't surprise you that this can also come up in systems of equations. You even saw it when you were graphing. So let's really quickly take a look at what this looks like. So for this system, 2x plus 3y equals 9. Negative 4x minus 6y equals negative 16. So elimination would be tricky with this one, okay? Because if you notice, our coefficients do not line up. However, notice 4 is a multiple of 2 and 3 is a multiple of 6. So what that's telling me is I can actually multiply that top equation by 2, and that'll help everything line up. Because then I'll have 4x plus 6y equals 18. I'm going to leave my bottom equation the same. And in doing that multiplication, now I can add these two together. And when I add them together, 4x plus negative 4x cancels off. 6y plus a negative 6y. Oh, that cancels off too. So that's what we mean by both variables canceling. Both of them end up dropping out of this equation. 18 plus a negative 16 leaves me with 2. All right, and this is that one case where we are left with a false statement. All right, 0 does not equal 2. So what that's telling me is this is a no solution. Right? That's what our no solution case ends up looking like. Both drop off and we get a false statement. Now, if we look at number 2, this one, even though this is elimination notes, I want you to look at this equation. Notice it is already solved for one of our variables. So I'm going to transition here. Because remember, at the beginning of this lesson, I told you, substitution, we're looking for an isolated variable. So I'm actually going to go back and use substitution on this. It will actually end up being the easier method. It is set up to use. So if I go back and think substitution, I'm taking that and putting it in for y. because that actually equals the y. So I'm going to have 20x minus 5. And now I'm putting in the 4x minus 3 where the y was. I'm substituting that in for y. Well, once I do my substitution, now I have to solve for x. Well, I'm going to distribute that negative 5. And now I want you to notice what happens. 20x minus 20x, it ends up canceling out. And we are simply left with that. 15 equals 15. We're left with a true statement. So this time our variables canceled out and we're left with a true statement. So remember, that is our infinitely many solutions. So just two quick special cases for you right there. So I apologize for this video getting a little bit longer, but I thank you for hanging in there with me. So what I'd like you to do is please make sure you have all of these notes taken and written down, and then in class we will continue doing more practice work on this elimination method. So again, thank you for joining me, and I will see you in class.